Okay, I'm going to write an equation on the board here that's used all the time in chemistry to determine how much energy as heat gets transferred. And we use this equation all the time. Usually what we do is we have a certain amount of water, and we use that certain amount of water as an energy trap into which the energy as heat flows, and then we can measure a lot of different energy changes using baths of water. The equation looks like this. Q, which stands for energy gained as heat, is going to be equal to M, which is mass, usually the mass of water, times C, which stands for specific heat, usually specific heat of water, but you should recognize that the specific heat depends on the material that you're using. And then finally times delta T, where this stands for change in temperature. Anytime you see this triangle and then a symbol in science, you should recognize that the triangle means change in. Change in what? Change in whatever follows the triangle. So in this case, the triangle T, or the delta T, means the final temperature. So you take the final state and you subtract from that the initial temperature, or the initial state. So for example, if we see a delta V, that's going to be the final volume minus the initial volume, where the capital Greek letter delta stands for difference. Difference by subtraction, and it's always final minus initial. So since we're often going to be talking about specific heat and the specific heat of water, we should know what that quantity is. C for water is going to be 4.18 joules for every gram for every degree Celsius. And what the specific heat of a substance tells you is it tells you how much energy is heat, 4.18 joules, has to be transferred to a gram of the substance to raise it by 1 degree Celsius temperature. Just to give you some other ideas, this is the specific heat for liquid water, but you should recognize that the specific heat for solid water is different. That's about 2 joules per gram per degree Celsius, and it just so happens that the specific heat of ice, the specific heat of gaseous water, which is steam, just happens to also be about equal to 2 joules for every gram for every degree Celsius of gaseous water. So again, the point here is that when you're using specific heats, you need to make sure that you're using the specific heat that's specific to the substance being studied. Let's do a quick problem with this. Let's say that I have 100 grams of water, and those 100 grams of water are going to be heated. So the 100 grams of water are heated from 15 degrees Celsius to 25 degrees Celsius. How much energy as heat was transferred to the water? How much energy as heat was transferred to the water? And again, this is going to be liquid water, for which we know that the specific heat of liquid water is 4.18 joules for every gram of liquid water for every degree Celsius that we want to raise the temperature of that 1 gram of water. So this should be pretty straightforward. We're just going to plug everything into this equation. We're looking for the energy gained as heat, Q. We'll plug in our mass, which is 100 grams. We'll multiply that by our specific heat for water, for liquid water. It's going to be 4.18 joules for every gram for every degree Celsius. And then we're going to multiply that by the change in temperature, which we need to remember that's going to be the final temperature, which is 25 degrees Celsius, minus the initial temperature, where we started, which is 15 degrees Celsius. And the last thing I'm going to do before I run through the calculations, I'm going to make sure that all the units are talking to each other. So I have a gram here and an inverse gram here, so that's good. And I have a degree Celsius here, and it looks like I have degree Celsius here as well, so all the units are appropriate for the equation. So now we can just run through the calculation. First I'm going to look at, well, let's do this first. Let's do that here. So let's see, my energy gained as heat is going to be 100 grams times 4.18 joules times inverse gram times inverse Celsius, and 25 Celsius minus 15 Celsius is a positive 10 degrees Celsius. And we're going to want to make sure that when we're doing these problems, we indicate whether the temperature change is positive or negative. And that will be important to determine whether the water has gone through an exothermic change in which it releases energy as heat, that'll be negative, or an endothermic change in which the water gains energy. In that case, the Q will be positive. If I look at my units here, this gram cancels this inverse gram when I multiply them together. And this inverse degree Celsius cancels this degree Celsius when I multiply them together. And the unit that I'm left with, the unit that survives, is a joule, which is a good thing because I'm looking for an energy, and energy is heat. So now, I'm just going to take this 4.18, I'll multiply it by 100, which will give me 418, and then I'll multiply that by 10, which will be 4,180 joules. And because this is positive, it'll be a positive 4,180 joules that the water will need to gain as heat in order to go from 15 degrees Celsius, the initial temperature, to 25 degrees Celsius, the final temperature. Notice the temperature of the water goes up, and the positive sign here indicates that Q is positive, meaning the water, our system, has gone through an endothermic change. It has gained energy. Let's run one more calculation. Let's say in this case, we have 25 grams of water. We'll set it outside, so it's kind of cool, but it starts. So we'll say 25 grams of water at 20 degrees Celsius cools to 10 degrees Celsius. Calculate the energy change in the water as heat. Well, we'll just set it up like we did before. Q is going to be our mass, which is our 25 grams. We're going to multiply that by the specific heat of liquid water, which again is 4.18 joules for every gram for every degree Celsius. And we're going to multiply that by the change in temperature, which in this case, our final temperature is 10, and our initial temperature is 20. So let's see, that's going to be 10 degrees Celsius minus 20 degrees Celsius. So this is the setup for this particular problem. I'll do this calculation first. So Q is going to be 25 grams times 4.18 joules for every gram for every degree Celsius. 10 minus 20 is negative 10 degrees Celsius. And notice I keep that negative sign there, indicating that the temperature of the water has dropped. My units, oh, they look good. They're all talking to each other. This gram cancels this inverse gram. This inverse Celsius cancels this Celsius, so the unit that I'm left with is a joule, which is good, because that matches the units of energy. Let's see, my Q will be in joules. And now I just got to multiply the numbers together. Now notice, when I take this positive and multiply it by this positive, that'll give me a positive result. When I take that positive result and multiply it by a negative, that's going to give me a negative. So in this case, Q is negative, indicating that the water loses energy. It goes through an exothermic change. And that's borne out by the fact that the water drops in temperature. Let's do the math here real quick. 25 times 4.18 times 10 That'd be a negative 10,045 joules of energy as heat that the water loses to go from 20 Celsius to 10 degrees Celsius.